So very good afternoon all. So very first question to your the kids. आपको हिंदी में सुनना है या इंग्लिश में करें? आपको हिंदी में सेशन लेना है या इंग्लिश में सेशन लेना है? टीचर्स आप एक अनम्यूट करके आप बोल दीजिए प्लीज. Deepak, you can give the permission.
I have given.
Yeah, thank you. Teachers, आप अनम्यूट करके बोल सकते हैं. आपको सेशन हिंदी में चाहिए या इंग्लिश में कंटिन्यू करूं मैं? Okay. So I'll start the session in English only then. Okay. Is my screen visible?
Yes, sir.
Okay. Good afternoon all. Myself Rajesh Kushalkar. I am heading the open source hardware initiative under the FOSSEE project. So today we have a session on Arduino from curiosity to innovation. Build, learn and invent. So before I start, I'd just like to show you a small video before I start. So there's a small video that I would like to show you. Audio is available?
Tanish was not an ordinary schoolboy. He was curious about how things worked.
Why does the fan spin so fast?
Good question, Tanish. Let's find out together.
At home, his curiosity turned into action. Every broken gadget was a new mystery waiting to be solved. One day, Tanish discovered something amazing: Arduino.
So code can control real things.
With patience and practice, Tanish built his very first robot.
It works! Wow! Where did you buy this robot? I didn't buy it. I made it.
That one sentence changed everything.
Can you teach me?
This is called the Blink program. Every journey starts here. Press the button.
I did it! The LED turned on.
Step by step, curiosity turned into confidence.
Wow! We're controlling it wirelessly.
Together, they built more than projects, they built skills.
Woo!
Next, drones!
Yeah, drones!
Years passed, but curiosity never faded.
Remember our first blinking LED?
And now, drones for the nation.
To curious minds, one open source tool, a stronger nation.
This robot helps us learn about science.
Hello. So hope you got a very basic idea what exactly Arduino is about and what all Arduino can do. I'll give you few more demonstration, but afterwards. So first we'll just stick to our topic now. So Arduino, from curiosity to innovation, build, learn, and invent. So this is the topic of our session today. So every child has got some curiosity in his mind. He always try to find it out how the things are working, how to make something. Very first thing is how things are working. So as a child, you must have always seen whenever you get something, very first thing you try to open it and see. For example, even a simple ball pen, you get it, you just try to open it, yeah, how to fill a refill, how to put up a ink in it and all this thing. First, your observations are like that. Or if you see, if you have got a car which runs on a battery, so you'll see how to put up a battery, how it runs the car. But once you have played with the car and everything, then you try to explore more how the wheels are rotating, where the motor is kept, how the motor is uh, getting the power and how it is working. So the curiosity should come from a child's mind, how the motor works. The moment I connect a battery, how the motor is moving, what makes that motor move. Okay, so it should not like that कि battery connect कर दिया तो it start working. No, you should know the back side why it is working. Similarly, that's a kind of simple curiosity that a child always has. Open the gadgets and see. You must have seen at home, you're working with remote controls. Okay, your television, your AC, everything is operated with remote controls. You turn on, you can increase the volume, you can decrease the volume. Okay, there are 40 different things on your keys on your remote control. But how each and everything, the moment you turn plus button of your channel, the channel changes, or plus button of your volume, the volume increases. What signal it goes? So that curiosity lets a child to learn something. Yeah, now this is something called as infrared, which is there in the remote control, which is received by the TV. Okay, so each button has got certain codes. That kind of code has been sent through the infrared that is received at the TV end, and the functionality works. So this is what you'll come to know only when you are curious about how thing works. Okay. Similarly, you must be very much interested in building robots, making drones, or invent some new technologies and all this thing. So everything starts with a curiosity, how things work and how your understanding about the working principle of the particular devices. Okay. So as I've told, when a car, you're just opening a toy car, you're seeing that motor is there. How does a motor work? How does a remote work is there? So this curiosity, that is the electronic part is there. Now, if you code that part, according to that, the thing will operate. So this is how the process comes. Like you have some electronics, you code something, you do some robotics or anything you do. So the robotic is just an example given, but it can be anything, and that innovation is happen. So what is Arduino? So Arduino is a small device. So we call it as a small program platform which lets students do experiments on it. So what are the different things in Arduino? We call it as input output. There are certain input, we give some signals or we tell something on our action. Okay, so the brain or the program of the Arduino controls that thing, it senses that part, and the output is given. So what is our, we call it as different sensors which are available and all this thing. Our body has also got certain sensors with us. For example, eyes, we can directly resemble to if you try to compare with a mobile phone, eyes is what? Your camera. Okay? Ear is your earpiece. Your speaking is your microphone through which it is going to listen. Okay? These are the, and touch sensor is there. Similarly, if you just see, if you are trying to go and hold a vessel, a glass which has got hot water in it, the moment you try to hold that hot water, immediately what happened? The moment you try to hold the hand, you immediately leave that thing. Why? Because the water is hot and you can't hold that glass because it is very hot. So how it is sensing? You are touching, your skin sends a signal to your brain. Your brain reflects back saying it is hot, leave it. So you got something, got input, the brain process it, now output is leave. Okay, this is a simple one of the example that I can try to give you. What is input, the process, and what is the output. Okay, so Arduino is a small programmable electronic brain where it reads certain sensors and controls the output. Okay, so as you see, I have given you the example of remote control. If I press the remote plus button for volume of plus button, the volume increases. This is the input. The plus button is the input and the output is volume is increased. Now if I press the negative button or low button, the volume decreases. So what you see, the input and the output, what you can see. Similarly, there are a lot of things that you can try to build it with Arduino. Is not only reading sensors, controlling robots, or it can be used in farm also, and a lot of things. So Arduino is like, as I've told, small brain. It sends something and the action is taken. Now, for example, you are trying to use some temperature sensor. There are a lot of sensors available that can be incorporated with Arduino. So now the moment there is a temperature sensor, Arduino do something and fans turns on. Now what does it mean? If I program my Arduino or my controller in such a way that if the temperature goes above 25 degrees Celsius, automatically the fan should turn on. Okay. So what's the logic? What's the input here now? The input is temperature. So sensor is continuously sensing the temperature. Now what's the logic given in Arduino? If the temperature goes above 25 degrees Celsius, the fan should turn on. Okay. Now suppose my temperature is 24, the moment it reaches 25, automatically the fan will turn on. Okay. And you will have, suppose now the program also says the same way also, it's a reverse way also. If the temperature goes below 25 degree, automatically, now if I say that if the temperature go below 23 degrees Celsius, the fan should turn off. Okay. Now if the temperature goes below 23 degree, the fan will turn off. So what is the input out here? The temperature sensors, what it is sensing the temperature is your input. And what is the output? Is the fan. Now fan logic, how we are playing it? If it is 25 degrees Celsius, the fan should turn on. If it goes below the temperature is 23 degrees Celsius, the fan should turn off. So who is deciding this part? Automatically the brain, Arduino, decides what your logic is input. So real life examples, what you can build with this thing is smart irrigation. So in the farmland and all this thing, many of the nowadays people use automatic sprinkler systems, automatic watering system. So this is basically, there is a small sensor called a soil moisturizer sensor. So it measures the moisture level in your soil. If you find the same again, if my soil level is so and so level, if it is a level 5, I should get water. Okay. If the level is, say, assume it is 3, I don't require the watering required. Now, the soil sensor again is the input. It senses the input, what is the measure moisture of the soil. If it is above 5, the motor turns on and it pumps the water. okay, to the field or anything. So you can do it as a simple small experiment for your household also. So right now in your home, you have to water every day. But what, suppose you have done a small pot is there where the water is filled and a small motor which pumps to the each plant. Okay, small moisturizer is there. It will detect whether there is no the sensor will detect there is the moisture is very low. The automatic motor will turn on. It will plant the pots. Okay, so you have automated. Now you don't have to bring a jug of water and fill it every time in all the pots. So you can automate this thing at home. Also try to do some experiments. Okay, similarly you can build robot. There's a home automation. The home automation is a simple thing. What you say is turn on the light by voice command. Turn on the light, turn on the fan. Okay, this is a voice command which I'm giving, and it checks it and turn on the thing. Another example is when this small devices, okay, right now what happened, there's a plant which is getting water by heat sense and all this thing. Now every house, suppose this home automation is done, all these small devices, the moment it is get connected to internet, the moment the small device gets connected to internet, it is called as Internet of Things. So your house is one thing which is connected to the internet. For example, I moved out from the office and I want, the moment I reach home, my room temperature should be 22 degrees Celsius, and the AC should be turned on automatically and all this stuff. I've just told it. So now my home is continuously monitoring my path. How much time I am going to take to reach home. Suppose it takes half an hour to reach. The AC, the home automation knows that it takes me only 15 minutes to cool the room. So it is not going to, the moment it is saying I moved from the office, now turn on the AC, no, he is not going to do. He is going to wait. The moment it reaches 15 minutes about to reach, then it will automatically turn on the AC. The moment after 15 minutes I reach home, I see the temperature is cool and pleasant, I can stay. Okay. So this is how the thing works when the small devices are connected to the internet. Similarly, nowadays there's a lot of issues for the weather station. What is the weather? Weather station is basically more on how much rain is coming, what is the humidity of place, what is the temperature of the place, and all this stuff. The air quality is another sensor. How you see what is the AQI of the city. Nowadays, many times you see the temperature and AQI of the cities. How it is told? There's a sensor which is available which tells you if the pollution level is good or bad, depends on the matter what it is collected from the sensor. Why Arduino is popular? Arduino is popular because it is very low in cost. Okay, many people can definitely afford it. So sensors are also very easy. So it's a small prototype board. So student or the makers can definitely work using this Arduino. Try to code it, assemble the sensors, try to code it and see the output. So it is called as prototyping. So prototyping means what happened? I am trying to design something before making a product. For example, you must have seen the smart watches which are available. So when it was in a very basic prototyping stage or anything, you must see a lot of wires and all these things are coming out of the display and all this thing. But once all the prototyping and everything is working, then they go into design of small unit and all this stuff so that it can come into the small form factors and all this stuff. So whenever you try to design anything, it very first thing comes in is a prototype only. But before any prototyping on anything, one is the design part, it always comes. That I'll talk to you further also. So why to learn Arduino? Because Arduino is a very easily available kits which you can program, learn electronics, design thinking, problem solving and innovation. I'll give you a small example of a problem. You should always see what is around you and what problem are people facing. There's a very small example that I can give is your classroom attendance system. How you can automate your classroom attendance system. How many people are students have come in, how many students are outside, how you are going to do that thing. Okay, so this is a problem. Now you are going to try to solve it. So you can apply certain sensors to it. Try to see, yeah, 30 classes there, 30, all the 30 students are there. One student, 29 only there, one student outside or absent or something like that can be done. So first is a problem statement has to be defined. What is the problem? Classroom automatic classroom attendance system. Now after that you are going to design something. So that is going to be a prototype. Okay, once you design that thing, then after the design coding and everything is done, then if it is working properly, you will try to fix somewhere and try to see whether all the things are working or not. Once you see everything is working fine, then you come for a small gadget. Now whatever you see, as I've given you the example of smart watches, initially they were very bulky, but what is the product out is a very small band which is available, and immediately we can wear it and use it. Okay, so this is what you can learn using Arduino. So Arduino is basically used for robotics, IoT engineers, electronics, AI hardware. Now what is AI hardware and all this thing? So you can just, I've given you a simple example of home automation, where it is thinking, it is checking how much time it is going to take. So whatever time is been decided, it is, the decision has been taken by the system. The person who has given the instruction that the moment I reach home, my room should be pleasant with so and so degrees temperature and all this thing. Okay, that's only instruction was given, but at the back end and everything, who is deciding? The system is deciding everything. Okay. So carriers, a lot of things like, as I've told you, for robotics, space, technology, smart cities, agriculture, medical devices. Now I'll give you for a few more example of medical device. Again, coming back to your wristwatch only, your smartwatch. The smartwatch shows you how much is your pulse, how much your SpO2, how much oxygen level you are having and all this thing. It is showing how many steps you have counted, how many steps you have gone. So how these are small sensors which are fitted into your smart watches, which calculates your steps. It calculates your heartbeats and everything and show you on your device. Okay. Now if you just take your mobile device also, there are a lot of sensors built in. Okay. So the sensors like this one, mobile device, mobile. Now you have this mobile with you. Now you are watching some video or some content on it. The moment you hold your mobile in this fashion, it will show you a small bar. But the moment you tilt it, you can see it as a full screen. So what this happened, what this tilt does, this is one position, this is another position. So what is happening inside that, it tells the system that now in this portrait mode or landscape mode, so I have to give in this particular screen, full screen has to be given. So there is a lot of sensors which are available on your mobile device also. Okay, as I've told you, camera is one of the sensor, touch screen is one of the sensor, your mic is sensor, your earphone, what you are listening is, the speaker is one of the sensor. This tilting and all this thing, we call it as gyro. Okay, that is also another sensor. So all the sensors are built in. You also have got the sensor which is built, which shows you how far you are. So it is measuring your geolocation. Okay, that is another sensor which is communicating directly with the satellite. Okay, so these are the various sensors which are available on your mobile device also. So as I've told, for medical device, lot of things are possible with electronics using Arduino, and some sensors you can build lot of other things. Agriculture, again the agriculture is a farmer who is far away from his this thing, he has to go early morning and turn on the pump so that it is the water is given to the field. But what, he can sit at home and monitor all that thing. So it is not required that he has to go early morning and do this part. Okay. So at the home only, sitting at a one place only, he will have all the things at his mobile phone. Ki what is my farm humidity level, moisture level, and all this thing, everything it can do it. Smart cities, again, smart cities, what is this meant by smart cities? Smart cities clean, traffic manage everything. Nowadays you can see how I can manage my traffic. Okay, the signals, how I can manage the more traffic, so I can divert more number of passengers, vehicles to go at one side, I'll stop at other side and all this stuff. So how smartly you can manage or divert the traffic to another route or something like that also can be done. It totally depends on the how you're managing the stuff. Again, there's a problem of garbage, lifting the garbage and all this thing. Now there's a, at one corner you see that it is not clean, the garbage is a fellow has not come and pick up the things. But what if some sensors are available, it is telling the municipal person that this particular area the garbage is full, come and collect it. Okay, so though there are some sensors which are available, it will automatically send the signal to the municipal and it will come and try to collect it. Now another example of your, I'll just give you, for example, your school building water tank. Okay, there are hundreds of students which are there in the schools, and many people are using water. But what happened if the water level goes down, the water is empty, so a person has to go up, check the this thing tank whether it is empty or full, and according based on that he will turn on the motor and all this thing. What happened if we try to automate this thing? So automating this thing is also very easy. So as I've told you, we can have a sensor available where it is sensing the height of your water level. Okay, if my water level is decreased 20%, less than 20, it's only available 20% or something, water level is available, it will send a signal to the Arduino. Arduino will turn on the motor automatically because that is programmed. Now it is 90 degrees full, it is full. Automatically it will send the signal to the motor to turn off. Now as the water level get decreased at level 20, again it comes, automatically it will turn on the motor and pump it. So you see, this process has been automated. So always try to design, because things are available, try to automate the system. As if the system allows you, try to automate it. Now we always talk about this thing as input and output. We call it as I/O. I stands for input and O stands for output. Now what are inputs? Input is an information given to the system. The very first example of a hot glass I have given you. The moment I try to grab the hot glass, the hand senses the water is hot, the glass is hot. So that sense goes to your brain. The brain says to leave it. Now same example as you can see the temperature sensor. The temperature sensor for the fan also, I have told you 25 degree is the input. So these sensors and different are sensors like buttons, microphone, temperature, motion sensors, and all these things are different sensors which are used as an input. Okay, and this input decides what should be the output of it. Now output is like LED turning on a motor, display something, and buzzer out, showing you buzzer out something, or moment of something. So these are the various things that you can think of. As I've given you, now at home you can see a simple example. You switch on the switch, the fan turns on or a light turns on. We switch it off, the same thing happens. So switch is an input and output is a light or a fan. Same way, if I program my buttons in such a way, if I press the button, the LED should turn on. How much time it should be on and all this thing, that I can decide it with a program in the Arduino. Okay. So simple examples, sensors, moist sensors, the water pump that I have already given you the examples. Okay. Now we'll go, before going to some demonstration and live things, I'd like to show you some other parts of also for what all things that we can do with Arduino. Hello.
Yes, sir.
Only one person is there, kya, now?
Yes, sir.
It's a school.
I don't know, sir. They have
Hello,
not done video.
hello, hello, Pumps. Can you hear? Hello. So these are the simple memory game which is there where a student can play and check his memory. So it starts with a very basic of remembering the things, and as the level increases, the difficulty level of your memory also increases. So again, this thing is also built with Arduino with ESP32. So where it controls the robot with your mobile device, and of course you can have the expressions also, the eyes and all this thing you can see is there. There is another so digital sand clock. So as you can see, the sand is dripping down. Okay. So you have to see, your mind should be curious ki how things are working, means how this thing has been made. Okay. If I turn it also, the reverse thing happens. Okay. So this is where we are trying to program an robotic arm to do certain job. So we are trying to program it now. So it will move in some direction. It will hold the thing. And it will drop. So this is the program, we have done it, and now it will automate. So you don't have to do the same work again, program it again and again. Now it is already programmed now, and now it is doing the same work. Okay. So this is a game what has been developed. So the whatever light color is coming, it has to be hit. Okay. So as the level increases, so you can see the level increase, the light comes very fast also. So if you miss that thing, if it reaches the first LED light, so you lose the game. So this is how it is done. So bring your ideas to life. So we'll definitely help you. Join the FOSSEE open source program. Will definitely help you putting your lab also. So we'll go to the demonstration now. Let us see the demonstration. I'll call my friend Pratik.
हेलो गुड आफ्टरनून एवरीवन। सो मैं पहले जानना चाहता हूँ कि सेशन हिंदी में चलेगा या इंग्लिश में, क्योंकि अभी हम लोग सिमुलेशन डेमोन्स्ट्रेशन पे जाएंगे, तो डिपेंड्स ऑन यू। आप अगर हिंदी में प्रेफर करोगे तो हम लोग हिंदी में प्रेजेंटेशन देंगे। सो मुझे यहाँ पे फीडबैक चाहिए फ्रॉम ऑल द 3 स्कूल्स। You can unmute your mic and respond.
प्रतीक, हैंड रेज करने के लिए बोल दो स्टूडेंट को डायरेक्ट।
KV school and PUMS, you can raise your hand and like tell us which language would you prefer to demonstrate the simulation platforms, whether you want in English or whether you want in Hindi.
If you want to Hindi, then raise your hand.
English, okay, fine. So first of all, so this is the ElectroBlocks platform. We will share the links with all the teachers from the schools so that they can implement this simulation platform. So it is a simulation platform used for Arduino. As you can see a breadboard in the simulation window, an Arduino, an LED. So this is the landing page. So on the left side you will see multiple blocks available. So ElectroBlocks allows you to do the hardware simulation in the block-based programming. So you don't have to worry about the circuit diagram, hardware, or writing the code. You just have to make sure that whatever code you want to write, whatever hardware you want to make the output, just the logic should be right. So just in this case, I will just start from the fresh. I will just dump this code, and since you can see there are no blocks available, you won't see any component or any sensor in the simulation window. So let's just start with a simple project of blinking an LED. So what does a blinking an LED do? It turns on the LED and it turns off, and in between there is a time for which the LED remains on and off. So the logic behind is you should first turn the LED on, make it keep it on for a certain amount of time, then turn it off, and then keep it off for a certain amount of time. So this will be the logic. For that, we will go to, on the left side you will see the LED button. From that you will just take the block outside and place it inside the loop block. So as soon as I bring this block inside, you will see the LED appears on the screen, and it is now connected to pin number 2. So I can change the pin number of the LED which is connected to Arduino. So let's say I change it to pin number 6. You will see the number here also has changed. We can also change the color of the LED. So let's say I want a green LED. You will see the green LED has appeared on the screen. So coming back to the logic of our blinking LED, we will need a time for that LED to be turned on for like let's say 1 second. So we will, from the time section, we will bring this wait block, and we can change the time here. I can edit it to 1 second, and again I want the LED to be turned off. So what I will do is I will bring this out, and since this LED has been connected to pin number 6, I will for this block as well we will kind of make it pin number 6, and we will make it off, since we want the LED to be turned off after 1 second. And we will again give a time block for to make sure that the LED stays off for 1 second. So as you can see, the LED has been connected to pin number 6. So LED color is red, LED, and so now we can start the simulation. So you can see there is a simulation play button. As soon as I click on the play button, you will see the LED is turning on and turning off. So for each 1 second, the LED is turned on, and after 1 second, the LED is turned off. On the bottom, you will see. So these are the steps that includes. So we have a option of going through step by step of the entire simulation. If you press the next step button, you will see the LED which has been turned on is waiting for 1 second, and also you can see here. I'll just zoom it in. So it is turned on. When I press the next button, the LED has been turned off, and in the simulation as well it is turned off, and it will remain off for 1 second. So this will go on and on. So since we are using the simulation platform and we have given the number 3 for the loop runs, it will run for 3 times. But when you go to the actual hardware, when you upload the code to the hardware, to the Arduino, the code will run in n number of times infinitely till you change and upload another code. As I mentioned that you don't have to worry about the writing the code. As mentioned, so this is the code which has been written by ElectroBlocks on the back end, and you don't have to worry about the code. You just have to make sure that the logic is right. So I will just explain it to you again. So let's say I drag this block inside the loop block, and for now there are no code written here. So this is the basic syntax for the Arduino. Void setup is where we write the details of the sensor or the components that we have been using, that we will be using in the experiment, and we give it the numbers. And in the void loop section, we write the code that we want it to be running for n number of times for the actual working. So when we drag this block here inside the loop block, you will see the LED which has been connected to pin number 6, this line of code configures LED pin as an output. So this line will come in the setup block, and also in the void loop you will see a digital write 6 high. So what this does is, we are given in a comment as well. So the defined pin, which is LED, it will turn it on. So the LED connected to pin number 6 will be turned on with this block. And when we add the wait block, a delay line has been added in the code. So just that way, all the codes have been written by ElectroBlocks on the back end, and you just have to worry about the blocks. So this is regarding the code part. So let's say over a period of time, you develop, like you get the hang of it, you develop all the skills that are required to for the simulation part, and you want to actually go to the hardware part, where you will be connecting all the sensors, the LED, and to the Arduino Uno, and then you want to write the code for it. But just before making sure that whatever code which has been generated by ElectroBlocks, if you want to check it, we have an option here to connect our Arduino Uno and upload the code. So what I will do is I will just connect my Arduino to the system and I'll try to upload the code. So right now I have connected the pin, the LED to Arduino pin 6. And we will just upload the code now. So after when you click on this, you will be asked to select the port, the serial port, which I have been selected now, and I'll just click on the connect. So once that code has been uploaded to the Arduino, you will see a message on the screen that good job, coding uploaded. So you can see the LED is blinking right now with 1 second delay after each interval. So suppose I want to change the sequence. I want to turn on the LED for 3 seconds and I want to turn off the LED for 1 second. So this loop of 4 seconds, where 3 seconds the LED will be turned on and 1 second the LED will be turned off. So I will upload the code again and you will see the pattern of the LED blink will be changed. So you can see the LED turn on time is far much higher than the LED turn off time. So that is what we expected the LED to be giving the output. And apart from that, we have a lot of blocks here for the Bluetooth, digital display, LCD screen, motor, RGB LED, along with the servo motor and stepper motor. In the sensors section, you will have analog sensors, button, digital sensor, motion sensor, RFID, temperature and thermistor. So let's just so this is where we develop a code or the experiment where we are just controlling the output. So what if I want to connect the output based on my input? So in terms of just imagine like you're sitting in a school and in a classroom you want to control the light. So how do you turn on the light? You press the switch, right? So if you want to replicate the same experiment, I want a button, a push button here, so that I can turn on the LED. So let's say I want a button, right? So in the sensors section, I have a button setup block, which allows me to set up a button where to decide which pin I want the push button to be connected. So let's say I decided to connect it at pin number 10. So you can see pin number 10 has been connected to push button and a press message is arriving here. So it is a conditional based. So it is a condition where you only when the push button has been pressed, only then the LED will be turned on. So for that we need to add if then block. So if the button is pressed, then the LED will be turned on. We will go back to the button section again and put out this block. Button 10 is pressed. So we will attach it to the if section. So if button is pressed, then the LED will be turned on. It will turn on for 3 seconds and it will turn off after 1 second. So for that, I will just zoom in the simulation area, and let's start the simulation here. Let's see how does this work. So here you can see when the button is pressed, the LED is turned on for 3 seconds and then it is turned off for 1 second. So this will go for 3 loops since we are given a number 3 here. But what if the button is not pressed? So in the button setup block, you have an option to select the status of the button. So if I uncheck this box, you will just realize there is a change in this simulation window that the released text appears, and the hand which was there when it was pressing the push button, it is gone now. So when you uncheck the box which is button is pressed, you decide whether you want the button is pressed or not. So for the condition where button is not pressed, the LED won't be turning on. You can see it is turned off for the entire duration of the simulation. But as soon as I make sure that the button is pressed, a hand appears on the screen, a message pressed appears on the screen, and then when I press the play button, the LED turns on for 3 seconds and it turns off after 1 second. Yes, till now do any of the students have doubts? They can raise their hand and ask the question. PUMS school, KV. Okay, so let us do another project. What we can do is we have a list of projects here in the project section. So this is automatic parking gate, where when a vehicle comes in the vicinity of the sensor, the gate opens automatically. So these are the block arrangement for this experiment, and the code has also been written here automatically by elector blocks. So what we will do is, this will act, the ultrasonic sensor will act as a sensor which detects any presence within its vicinity, and if the object is near to 10 centimeters, the servo motor which is acting as a parking gate, it will open and it will rotate to 90 degrees. So let's start the setup code. So as you can see, the distance what we have given is less than 10. So that is the reason the servo motor did not rotate. But as soon as I enter distance as 20, the servo motor rotates to 90 degree. So when any object comes in the vicinity of the servo motor, we can decide the distance where we want the other component to be triggered, and that way we can play with the sensors. So another project where with the using LED matrix, 8 by 8 LED matrix, you can actually draw any object or any diagram that you want using the checkbox with the help of ElectroBlocks platform. And when you just play the simulation code, you can see what we have done is, we have done a smiley code where the smiley emoji is blinking its eye. So you can see this eye is blinked for continuous. So you can make multiple design with this. We also have this platform for Arduino on Cloud. So let's say after multiple iterations, you develop confidence to actually work on the hardware, and you want to make sure that you are the one responsible for connecting the hardware, connecting the wires, writing the code on yourself. So this is where this platform comes into picture. This is Arduino on Cloud platform. Uh, if you go to the launch option and you launch the editor, you will see this UI. So here in the gallery part, we have given multiple working experiment which you can use for reference. So suppose we want to use counter, just to make sure that whenever a push button is pressed, it counts the number. So this is the circuit diagram. What you can do is, so on the left side, the code is written. Here is a play start simulation option. You can start the simulation, and so this push button allows you to press and count the number. So this is right now it is 0. So as long as I'm pushing the push button, pressing the push button, the count will increase 7, 8, 9, 2, 4, 6. So like that way. So let's build a simple LED blink circuit again using this platform. What you can do is, uh, on the left side you will see a register breadboard. You can drag this component outside, just like you drag the block in the electroblocks platform, and you can drag the Arduino Uno board as well. LED in the output section we have buzzer, LED, motor, RGB LED, servo motor, 7-segment display, and LCD 16:2. In the input part, we have push button, ultrasonic sensor, PIR sensor, those sensor which collects the value from the environment and feed it back to the Arduino. Those sensor come into the input section. So what we will do is, we will just take the LED out in the area and just bring out the register. So you can see the LED part. The LED has 2 legs. One is positive, one is negative. So you have to make sure that the positive, you connect the positive leg to the Arduino pin, which is from 2 to 13, and the negative leg should always go to the ground of Arduino. So what you can do is, you can just place the register here. So suppose if I want to connect the negative leg to the ground of Arduino, I'll just press once on the negative leg. The wire will appear on the screen as soon as you drag the cursor, and then you can select the orientation. You can make sure that you can connect to the right pin of Arduino, which is ground, and I'm connecting it to ground now. For this part, positive leg, what we will do is we will connect to the register first, and then via register we will connect this wire to pin number, let's say 9. So we have connected to 9. So what these do is, generally, ideally what we do is, ideally whenever we connect anything ground or negative, we use black wire. So we will keep it, the ground connection, as black wire. But for the LED, which is connected to pin number 9, we can change the LED color of the wire. So what we will do is we will just click on the wire, and you can see a a dialog box appears on the screen. So from here we can change the wire color to red. Similar to that, we can also change the wire of this wire to red color. So ideally this is the circuit, but suppose if you want to make it look good, with the orientation, with the aesthetic, so we have an option of auto arrange wire. We will just click on it and you will see that wires have been auto arranged like peacefully. So what we can do is you can go to the code section. So like that, like I showed it to you in the Electroblocks platform, that this is the void setup and void loop section. Void setup is where you write the pin numbers which has been connected to Arduino. So in this case, what we will do is we will write the code for LED which is connected to pin number 9 and make it output, since it is an output component. And in the code section, we will write the code for LED to blink. So what this does is we will first keep it high, so which will turn on the LED. Then we will keep the delay as, let's say, 3 seconds. So that is why we are writing 3000 milliseconds. And when we want the LED to be turned off, we will write it low, and again a delay of, let's say, 2 seconds. So we have written the code. What you can do is you can just start the simulation and see whether the LED is turning on for 3 seconds and turning off for 2 seconds. So as soon as I play the start simulation button, yeah, on the bottom screen you can see a message appear in the green color, which says that whatever code that you have written, it is the right code. The logic behind is right. It does not necessarily mean that whatever code you have written should work with the hardware that you have chosen to work with. So as you can see, the LED is turning on for 3 seconds and then it is turning off for 2 seconds. So let's say a student makes a mistake in writing the code. Let's say they do not write the semicolon in both the lines, and they just try to upload the code. So you saw earlier that a message appeared in the green color because it was the right code. But since I made an error in the syntax of the Arduino code, it is showing me the message in the red color. So this allows me to get a feedback from the platform that whatever code that I have written, it has an error in it. So I can just make sure that the error is gone, and I'll just so this part, the error part, the syntax part, you will learn over a period of time, and then you can just start the simulation again, and you can see all the LEDs are working fine. So for that, so what we have done is I'll just share the document. So this is the document that we have created for the Arduino on cloud. So it has experiment from blink of LED, control LED with push button, display scrolling text, motion sensor, gas sensor, servo motor, street light. So what it does is we give the aim of the experiment, where we tell you what the experiment is all about, what we expect at the output. We also mention the component which are required for this particular experiment. The experiment, whatever component that are going to be used in the experiment, we give a brief idea about it. How does it work? How to program it? And let's say in case of gas sensor, so you can see we are giving the information that gas sensor is an electromagnetic device which uses a position feedback to control its motion. So we also give a circuit diagram so that you can take a reference from it and make it your own circuit diagram in the simulation. and we also give a code. So suppose sorry, suppose if you are confident enough to write your own code, you can write it. If at all you face any difficulty while writing the code, you can just take the reference from here. We have also given explanation of each line of code, so that it makes you understand what the code is all about, and it helps you writing the code for the next time. And at the bottom, we give output GIF, so that you can have an idea that this is what the output is expected after the experiment. And once you are done with all this, we just try to tweak the few things, make few changes in the experiment, and we give an assignment, so that you can learn, you can write your own code, and making sure that you understand the concept behind all the sensors and writing the code. So you can go, you can find this document on the this simulation.fossee.in, and you can have an access of it, so that it makes it easier for you to understand all this experiment. So coming back to the gallery, let's just go with a few examples. Let's say I want to use a potentiometer to control the servo motor. So let's say I want to rotate this servo motor using this potentiometer. So we have already written the code, so we won't be looking into the code. Sorry. So as you can see, the analog value is 0, and angle given by the servo motor is also 0. But as soon as I'm changing the values, the analog value is also increasing, and the angle is also increasing. So depending on the orientation of my servo motor, so you can see as I'm changing the value of the potentiometer, you can see the servo motor is also changing its angle. Let's see another example. Let's see the LCD with breadboard. So a simple message of Arduino on cloud will appear on the screen, and we have written the code for here. So we are setting on the first line, simulations word will appear, and on the second line, on cloud word will appear, and this will go on and on until for eternity. So when we play the simulation, this message will keep on coming, simulations on cloud. So let's say I want some other text on it. So let's say I'm changing it to Arduino on the first line, day 2026 on the second line. So let's say I start the simulation. So you can see Arduino day 2026 appearing on the LCD. So you can decide what text, what letters you want to display on the screen. Just you have to make sure that all the syntax, all the data have been fed to the code correctly. So for that, you can take a reference from the document which I just mentioned. Yeah, this is document. So in here we have a total of 12 to 13 experiments which you can look into, and yeah, so code has also been explained line by line, so it makes it easier for you to understand. Okay, the simulation part is over now. So I will ask Rajesh sir to come in, and he will have an address to all the schools, and he will talk about what are the future options that you can look into for the FOSSEE open source hardware group. Yeah, so he'll be able to give you more information on it.
You are mute, sir.
Hello all. So you have seen basically how we program the Arduino. You have seen both the things, ElectroBlocks and Arduino on Cloud. So ElectroBlock is a platform where students don't have to do anything. Means they just have to simply drag and drop the blocks, and the moment you drag and drop the block, it generates the circuit automatically, and the code is also written automatically. Students have to just focus on the block programming. So in this thing, students learn drag and drop block, create a circuit automatically, which is an auto-generated code is also there. So students who don't have the basic knowledge of programming and all this thing, they can definitely go with the ElectroBlock first. But ElectroBlocks also generate a code. So each block, the moment I just drag and drop one block, what code is generated and all these things, the students can also see through it. So they'll come to know, okay, this is the thing and here's how it is done and all this stuff. Okay. Next, you come to Arduino on Cloud. So both our platforms are online. So you don't require any components or you don't require any Arduino to it. You can learn Arduino programming using drag and drop or using the cloud. The cloud platform allows you to drag and drop the components, wire it. After wiring, you have to write a code in C and then do the simulation. So there are more number of sensors which are available in Arduino on Cloud. So it's up to the school how they take it for the very new students who are very new to coding, they don't know the coding, they can always start with ElectroBlocks. And once they are through with ElectroBlocks, they can definitely come to the Arduino on Cloud. So as we always prefer students to go with the simulation model. So simulation model helps you to learn Arduino coding, do the simulation online. So no hardware is required. So if your school is not having any hardware or the kids are not working or kits are not working, Arduino kits are not working or anything, they can definitely do with the simulation mode itself. Okay. So we always prefer first, whenever you are trying to design anything, first you should do with in the simulation mode. After the simulation mode is finished, then you can go with the actual hardware. Okay. So as we have shown the projects, different projects, what has been done, smart weather, all these things I have already explained to you. So again, so what is FOSSEE? So FOSSEE can help your school in setting up the STEM lab or robotics lab in your school. So where you can learn Arduino first, and we have a curriculum developed for it, and we can always go through this curriculum and we do the different experiments through the curriculum. So I ask the teachers so this forum is now open for the students to ask questions. So please unmute your self, and if you have any queries, you can ask. KV Lucknow? KV Lucknow, is there any teachers there with you? Hello? Is there any teacher? Please unmute and you can ask the questions. So there's one small request to all the teachers. Yes, yes, yes. PUMS? There's a small request to all the teachers. Please fill the feedback form and please upload the photographs and attendance sheet of the students. So it will help us to generate the certificates for the students also here. Both KVs, any teacher is there with you? I can see only students. PUMS? Any queries? Please unmute yourself and you can speak. Hello? KV, any teachers available with you in your class? KV? Any teacher is available in your class? Hello? PUMS, do you have any queries, questions that you want to ask or your students want to ask? Okay, no doubts. KV also, I think so. There are no doubts. Because I have kept this half an hour session only for doubts only. If there are no doubts, we can end the session. Both KV teachers are there with you. Hello? Is teacher present with your class? Okay, if there are no queries, let's end the session. Okay. Thanks a lot for joining. Bye-bye.